This is RPM 2000, serial number 481000Y, built in October of 2000. That's right when a huge number of the systems got built. This has been upgraded to the latest firmware over the years. It's switched on. I've taken some panels off to illustrate what's going on a little better. I've loaded a 2-inch indium phosphide wafer there on the 3-inch stage. We can fit into 6-inch stage if needed. It's 1.55 micron sample, and so I'm going to go and log into the software here and load the sample. So I got a warning that I don't have vacuum. There is no vacuum here, I'm afraid, so that's normal. And despite the lack of vacuum, I think the 2-inch wafer won't shift around very much on that 3-inch puck with the set on. So I want to turn on a laser. I have a nearly new 532 CW laser in this, and a 785 power adjustable diode laser, and that one we can request a power, so I'll go for about half of the 50 maximum. It will probably give me nearly all of it anyway, and it will normally ask for some stabilization time. I guess I haven't configured that properly. About 5 seconds is plenty for that kind of laser. So it's reporting 53 milliwatts, which is very close to its maximum. Probably is its maximum. And we'll have a look at the wafer under here. So this single spectrum window, I can select between 3 gratings, and they're listed as 150, 300 and 600 grooves per millimeter, and then the blaze angles, which is peak response wavelengths of 500, so about 750 and 1250. So for this type of wafer, this 150 grating at 1250 optimized wavelength is the appropriate one. I have a silicon CCD array in here that's got 1024 pixels. That's considered a wide one, so that's good for looking at VCSEL type samples. We also have an INGAS array. The silicon CCD will do about 400 to 1100 nanometers sensitivity. The INGAS array is going to be good for maybe 900 up to about 1650. So I've got a selection of filters in here. I have a 570 long pass filter, that's for excluding the green 532 laser from the light that reaches the monochromator. I have an 850 nanometer for doing the same with the 785 laser, so I'm going to choose that. And then I've got a bunch of apertures to cut down the signal in case it's much too bright. Typically this was employed in a VCSEL foundry and originally, and those give a lot of signal. So we're looking at 1550-ish. My 100 micron slit is pretty optimal. Everything else looks fine. I'm going to acquire. So that's going to go ahead and move the grating in the monochromator, which is quite a quiet motion. I can just about hear it. And we're looking right in the center of that wafer. Our position is reported at 00, 0. And the 150 grating being the furthest out on the grating turret takes a minute or two to swap to. There's a limit to how fast you want to drive your monochromator turret. So there we go, we get a nice signal at 1541.5. I haven't actually calibrated this instrument yet, but it's not a long way from calibrated. On this sort of shaped peak, I prefer to use this threshold analysis, which will mean that we find the peak at 90%, the midpoint at 90% of the maximum signal. So just reapply that to apply the new one. So that shifts it a little bit to the shorter side, basically because the peak is slightly asymmetric. So I'm going to turn the 532 laser on now, the green laser, and maybe take a map.